Hi guys, I think you'll recall back in chapter 3 we did some conversions where we went from molecules to and from moles, and we used Avogadro's number for that, and that's 6.022 times 10 to the 23rd. And then we went from moles and back to grams. And to do that, we use the periodic table. We use the molecular weight. Molecular weight. But when we did this, we did it only with atoms. Well, today we're going to start doing this with molecules. And since we've learned how to name these things, this is actually an acid, so you don't know it yet, but you will soon. I just selected this one because it was the most complex. It goes all the way from grams and it wants me to go to molecules, so I'm starting here, going all the way over here. This step remains unchanged because this doesn't matter whether we're talking about ions, atoms, elements, or compounds. This one, however, we now need to calculate a molecular weight based on this formula. And as you know, that's telling me there's 2 hydrogens, 4 oxygens, 1 sulfur. So let's first get together what the mass of that is going to be. So hydrogen I have 2 of, sulfur I have 1 of, oxygen I have 4 of. Looking at my periodic table, hydrogen has a mass of 1.008, sulfur has a mass of 32.06, and oxygen has a mass of 16.00. So I get out my handy dandy calculator and I say 2 times 1.008 plus 1 times 32.06 plus 4 times 16.00 equals, and I get 98.076. And that's going to be grams for 1 mole. So I'm now ready to start with the data in the problem, and I want you to set it up exactly as I do. Do not take any shortcuts. Do not leave out anything, or I will mark it wrong even if the answer is numerically correct. So you start with the data in the problem, which is here 25.0 grams of H2SO4, and I need all of that at my starting point. So 25.0 grams H2SO4, and I like these little lines because then I know everything above this long line I multiply by, anything below that line I divide by. Makes it very simple. And I know that this unit has to cancel with whatever I put down here. So this is the same as saying 98.076 grams for 1 mole, or I could say 1 mole of H2SO4 for 98.076 grams of H2SO4. Which one of these 2 factors do I want? Well, I want grams to cancel out, so I have to put grams at the bottom. So I'm going to put 98.076 grams H2SO4 for 1 mole H2SO4. And that way grams of H2SO4 cancel with grams of H2SO4. And I'm in moles of H2SO4. This, however, asks me to go all the way to molecules, so I need to continue on, and I'm going to use my roadmap. And so now I want to go from moles to molecules. I'm going to use Avogadro's number, and that's molecules, and I need to write that out, of H2SO4 for 1 mole H2SO4. You see why I had to write it out here, because mole and molecule start with the same first 3 letters, and so I have to write out the whole thing. So I want moles to cancel because I have moles on the top here. I need moles down here, so the way this is written is correct. And so 1 mole of H2SO4 is 6.022 times 10 to the 23rd molecules H2SO4. And now moles of H2SO4 cancel with moles of H2SO4. And I'm coming out in what it's asked me for, which is molecules. How many molecules of H2SO4 are there in this many grams? So now I'm ready to get my calculator back out. And I'm going to start with 25.0 divided by 98.076 and then times 6.022. And remember, we do not use times 10. To put in times 10, we hit the second button and our EE button, and then we just put in this exponent, which is positive 23, so just put in 23 equals. And I have 3 significant digits in my starting point, so I'll have 3 in my answer. So 1.535 times 10 to the 23rd molecules of H2SO4. However, again, I said there are 3. Here I have 4. I didn't round it or anything, so I'm going to round it off here. This 3 should round up to a 4, so it's going to be 1.54 times 10 to the 23rd molecules of H2SO4. And there's my final answer. So, again, this reviews several topics. It reviews the concept of going from grams to moles, moles to molecules. It reviews molecular weights. It also reviews setting up our stoichiometry, making our units cancel, and significant figures. So, yes, I will be looking for all sorts of things with these problems. Anyway, if this is complicated for you, you might want to go back to Chapter 3. It's still published on Haiku, and you can look at the simpler ones with just one element there, and then try and do the ones with the compounds. So, again, don't forget to print out your worksheets, and I'll have that posted on the website soon. Bye.